Here we have the 2006 connected particles question. Two particles, mass 0.4 kilo and 0.5 kilo. We keep them circles over here. So we have 0.4 g coming down and 0.5 g. They're both connected to these strings which have tension, and the acceleration is going to be down in this direction. So this guy's going to go up. So the system's released from rest as always. Find the acceleration in terms of g. So let's start with 0.4. It's going up, so t is the direction we start in. Minus 0.4 g is equal to ma, 0.4 a. And then we have 0.5 g coming down, minus t in the opposite direction is equal to ma, 0.5 a. So we have 0.1 g is equal to 0.9 a. So a is going to be 1 over 9 g, or just g over 9. ms to the minus 2. And then after falling 1 meter, s is equal to 1. The 0.5 kilo strikes a horizontal surface and is brought to rest. The string again becomes taut after t seconds. Find the value of t correct to 2 dp. So s is 1. It was released from rest. We've just worked out the acceleration of g over 9. And we can definitely get the speed that it hits the ground at. VUAS, v squared is equal to u squared plus 2as. So v squared is equal to twice g over 9, with u being equal to 0, times 1. So v squared is equal to the square root of 2g over the square root of 9, so over 3. So, sorry, that's v. I've done it in one step there. That's v. Square root of 2g over the square root of 9. That's right. So now that's transferred to the 0.4 kilogram, which is now going to go up with gravity pulling it back down. So a is equal to minus g. The speed it has before it stops, it's going to go up and stop when the velocity is 0. And the speed it has is this square root of 2g over 3. So we should be able to find out t from here. VUAT, v is equal to u plus at. So it's going to stop at the top before it comes back down to become taut again, and u is equal to the square root of 2g over 3. A is going to be equal to minus g times t. So gt will be equal to root 2g over 3. So t is going to be equal to the square root of 2g over 3g, which is, as a decimal, 0.15 seconds. So if it's at this position, the other one's on the ground, it goes up, stops, and then it comes back down, and the distance is going to be the same. It's going to stop, so the velocities at some point at the end will be the same. The accelerations are going to be gravity both times, which means that u will be the same going back down, so the 4 variables are equal going back down, so the time will be the same. So if we multiply that by 2, it will be 0.3 seconds before the string becomes taut again.